Okay, so today we're looking at section 3.1, which is on extreme. By the way, it is now almost November, and we're just now getting into chapter 3. So it seems like we're going slow, but in some ways it seems like we're going really fast, doesn't it? Okay, so we're going to look at extrema on an interval. Forward, there we go. And here are the key steps for finding extrema on a closed interval. I should point that out. This is important. In fact, on some of your problems, they might ask you to find the extrema on a closed interval, and then they might just say, what's it on an open interval? And if we look back at the warm-up we just did, we could see that on both those problems, it actually had maximums either way. But anyways, the first thing we're going to do is find a critical number. By the way, does anyone want to tell me what a critical number is? Besides Megan? Yes, Lisa.
Is it when the derivative is either 0 or do not, or does, d?
Lucy, that is so important. In fact, that is the most important thing I can say to you today. Guess why they call it critical? Because it's important. It's super important. Every problem that you do basically in this chapter, one of the very first things you're going to do is you're going to try to find the critical numbers. Critical numbers, by definition, as Lucy just recited, is this. It is either when the derivative is 0 or, and I should be careful, the first derivative is 0 or the first derivative is d and e, does not exist. You need to know that. If you can't do step 1, you will not do the rest of the problem. Okay. Step 2, you're going to evaluate the function at those critical numbers. Step 3, you're going to evaluate the endpoints. And this, by the way, the endpoints is only when it's closed. I'll point that out. No pun intended. If it was an open interval, you don't need to check the endpoints because if it's open-ended, guess what? There aren't any endpoints, right? So that's how it makes it a little bit easier. And I should note that there's some functions that don't have mins or maxes. Okay. So for example, this is a cubic curve, right?
Yes.
What's its if we don't have endpoints, does this guy have a maximum?
No.
Nope, it goes off to infinity, right? Does it have a minimum?
No.
No. By the way, I should mention this as well. Extrema is just a fancy way of saying maxes and mins. That's just a fancy word for maxes and mins. Okay. Any comments or questions on this? Okay, so let's look at an example. Ooh, there's an interesting function. And I'm not even going to graph it. And I bet, I don't know, you raise your hands. Raise your hand if you know what the graph of this thing looks like. Probably none of you. Let's see if we can figure out what the absolute extrema are. Okay? And this just says extrema. So that means we're looking for mins and maxes. Oh, by the way, we're doing it on a closed interval. So that means we've got to follow those steps that we just talked about. And the most important step was critical numbers. So I'll write a 1 here. We're going to find, and you'll see me write it as C#, which by the way happens to be a programming language if you're a computer nerd like I am. But C pound there, that stands for critical numbers in my book. Okay, so we're going to find the critical numbers. So let's go ahead and do the derivative of this function. What's the derivative of 2x?
2.
A 2. What is the derivative of negative 3x to the 2/3 power? Well, we got to do the power rule. And I'm going to show all my work here. So that's going to be minus 3 times 2/3 x to the 2/3 minus 1, right? I'm showing all the work because you might be taking notes and you might not be as good as differentiation as I am. So that means that this is equal to 2 minus, okay, so let's do a little cancelization here. Cancel. So that leaves a 2 there, that's nice. And then it's going to be x to the, I think that'd be negative 1/3 if I'm not mistaken. That'd be negative 1/3 because 2/3 minus 1 is negative 1/3. In other words, f prime of x is equal to 2 minus 2 over the 3rd root of x. And we're going to figure out when that thing is equal to 0 or d and e, right? So this is where the algebra part comes in. But before we do that, if you guys don't mind, I'm going to write this in a slightly different way. I'm going to get something called a common denominator. You might be familiar with that. So the common denominator here would be the square root of the third root of x, I'm sorry. So that'd be 2 squared, or third root of x over the third root of x, and then minus 2, if I'm not mistaken. Yeah, that looks good, doesn't it? And we are really interested in when this is equal to 0 or d and e. And I'll put a little question mark. And now what I'm getting ready to say is going to be really important for the rest of this chapter. In fact, I should maybe emphasize this right here. I'm trying to find those critical numbers, right? I have a fraction, and I'm curious when it's 0 or d and e. When will it be d and e?
When the denominator is
Correct. So f prime will be d and e when denominator is equal to 0. Agreed? In other words, when the third root of x is equal to 0. When is the third root of x equal to 0? When x is equal to 0. Oh, and I better be careful. I'm about ready to make a very costly mistake, and I need to point this out right now. We need to make sure, and I know I'm saying a lot, and I'm recording this, so you might want to rewatch this. You need to make sure that this is in the domain of the function. And I should have said this maybe earlier when Lucy made her point, because she nailed it. A critical number has to be in the domain. You can't have a maximum or a minimum if the point doesn't even exist in the first place, right? And in this case right here, can you put 0 into that function and will it give you out an actual number? The answer is yes, because 2 times 0 is a 0. And 3 times, by the way, what's 0 to the 2? What's 0 to any power, basically? 0 times 3, which is 0, so it's a 0. It is in the domain. Yes?
Is 0 to the 0th power 1?
Indeterminate form. We'll talk way more about that when we get to chapter 7.
Okay.
0 to the 0 and infinity to the, well, I think infinity to the infinity might be infinity. But 0 to the 0 is, we're not sure. Yes. Are you guys with me so far? By the way, how many critical numbers have I found? 1 critical number. Now I need to figure out, by the way, I just figured out when f prime was d and e, correct? So now let's do it in, let's say, blue. When is f prime equal to 0? When the numerator is equal to 0. I think being in class is really helpful. Because that's when you get to actually get those questions answered and hear the teacher who has way more experience at this stuff than you do say the important things that need to be said. All this stuff is in the book. You could look at the online book and get it all. So when is f prime equals, so that's going to be when 2 third root of x minus 2 is equal to 0, right? And by the way, you'd agree that the 2's could be factored out there, right? So this would be 2 over.
So that's going to have to be equal 1.
Yeah. Therefore, x equals 1 is a critical number. By the way, could we plug 1 into, it turns out this domain up here is all real numbers. So yes, it's all real numbers, so we're okay. So I claim that our critical numbers are these 2 guys right here. We have 2 critical numbers. Now, here's the important thing, guys. Once you've got, and like I said, those critical numbers, I said this was the key, right? I am telling you, those are the values that you have definitely got to check. You have got to check those guys. if this thing has a relative or a min or a max or a relative min or a relative max, which we'll talk about when we get to section 3.3, it has to happen at those values. Okay. However, in this case, since we're talking about a closed interval, let's go back to this guy right here. This guy here is what we call a relative min, right? If I go to here, in terms of my interval, this would be the absolute maximum of that closed interval part of the curve, correct?
Yeah.
And similarly, this would be the absolute minimum, correct? Mm-hmm. But if I get rid of those endpoints and I say the whole function, does it have an absolute min or an absolute max then?
No.
Does that make sense?
Yeah. Yes.
Okay. So let's go ahead now and finish this guy out. So remember 0 and 1, that's going to be helpful. Oh, and by the way, what are our endpoints? -1 and 3. Let's see here. So what we're going to do here is this. We're going to do x. We're going to do, actually, let's call this f of x. We'll do x and f of x. We're going to put -1. We're going to put 0. We're going to put 1. And we're going to put 3, I think. Remember, and I'll make a little note here. These two guys were critical numbers on the curve. And then these two guys, those are endpoints. Right?
Yeah.
So you need to test all 4 of those things.
Can you plug this into the original?
That is correct. So we just need to plug them in. So let's go ahead and do that. And I think the function, let me see if I can remember this.
Do we plug it into the original equation?
Yes.
That's what she just asked.
Oh, I'm sorry.
It's okay.
I
I think the original function was f of x equals 2x minus, wasn't it 3, the x to the 2/3 or something? Or
Yeah.
2/3, right? Okay, sorry. We'll make sure we get this correct. Now, guys, I'm probably going to need some help with the calculator. So someone get your calculator ready, because here in a minute I'm going to have to figure out what the 2/3 power of something is, and I'm not going to be able to do it. I can do it for 0. We already did this one, didn't we? Didn't we say that was 0? Let's do it for 1. That's another one I think we can do in our head, right? If I plug 1 into these two guys, what will the answer be? Well, it'd be 2 minus 3, which is,
-1.
would you guys agree that's a pretty easy one to do in your head, no pun intended?
Yeah.
Now, the harder ones are the -1 and the -3. So I'm going to need somebody to help me out. Let's have, Dagan, would you do me a favor? Would you carefully plug -1 into that function and tell me what the answer is? And then, Ravana, do you have your calculator going by chance?
I have it.
Did you already plug 3 in there?
No, I haven't.
Would you plug 3 in there, please, and let me know what you get? And it's probably going to be a decimal. I can't remember if -1 is. It might or might not be. It probably isn't, but I mean, we could calculate them to a certain degree of actually without a calculator.
I was supposed to plug in -1.
Correct.
I got -5.
-5. Okay, we'll go with that.
I don't think I got the right answer.
Okay, what'd you
It
get?
is a decimal.
What is it?
Negative.
Uh-huh.
-0.24.
You got the right answer.
Oh, okay.
Good. Can you give me one more decimal place?
2402.
Okay, perfect. Okay. Now, I'm gonna stop here because the problem's basically done now. And I haven't answered the question, but I want to go back to make sure we're okay. And I'm gonna pause. I'm gonna leave it. We're gonna let that keep going. Okay. Most of the work on our part was finding the derivative and then figuring out the critical numbers, correct?
Yep.
Once we found the derivative, which allowed us to find the critical numbers, we plugged the critical numbers into the table in addition to the endpoints. Now, what we're going to do is use our common sense, I hope. What is the biggest of these numbers? 0. That's the max. I am telling you the maximum of f of x is 0 at x equals a 0. What's the minimum?
Minimum is -1 at -5.
Yep. The minimum of f of x is negative 5 at x equals negative 1. Stop my video now.